Hi, welcome to part 4 of my attempt to convert a cheap toaster oven to an SMD reflow oven. I'm going to go through the progress that I've made and then we'll look at doing a test reflow. As you can see, I have replaced the original control panel with a new one which is 3D printed and then just covered in some wood grain vinyl to hide the 3D printing marks. I went through quite a lot of stages to get to this point, and I'm quickly going to show you the assembly of this current control panel now. Here we can see the PCB that I had made from JLC PCB, and it's just a basic copy of the original development board that I made. So it's quite simple, and I still have all the headers on so that everything can be taken on and off as needed. So we have the screen that I've changed to be vertical, the rotary encoder just like before, and I've taken one of the knobs off the old control panel, and then a simple button at the bottom, and then at the top we just have a USB port so that it can be programmed when needed to be. I've taken out most of the stuff that was in there before. There wasn't a lot, but I've put in a small socket on the back for a mains plug. We have the SSR mounted to the back of the chassis. The bottom here is my Meanwell power supply, the black module that we've looked at before. And there we can see the circuit board with the teensy and the thermocouple module on the back. The screen is mounted on the front of that, just like we saw in the pictures of when I assembled it. Let's power this up. So you can see that I flipped the screen around so that it's vertical, but it works in the same way with the rotary encoder. We've added a function just to monitor the thermocouple. So that just shows the temperature with the min and the max and the graph along the bottom. We can exit out of that by pressing the encoder and it will go back to the menu. I'm still using the same thermocouple attached to this circuit board, but I've been optimizing my graphics routines and I found that this was too sensitive and too twitchy. And where I was waiting for the temperature to stabilize, it would never stabilize, and I have had to put in some averaging, so it would average the last 10 readings, and then it will round those average readings between 0, 0.5 and 1. So this then gives me back a smooth reading that I can use in the routine. I do have a new thermocouple on the way, which was made, and it has a very small enclosed sensor on the end. So I'm going to try that, and hopefully that will be less sensitive to the changes, but still be sensitive enough to react as quickly as I want to. The basic routines are the same as we had before, where we're heating up to a temperature, waiting for the temperature to stabilize for a period, and then heating again. But what I've done now is I've changed this specifically for a reflow profile. So it builds up to 150, waits for 2 minutes to do the soak, builds up to 240, waits for 1 minute, and then stops. Now I still need to tweak it because it's taking a little bit longer, but I've tested it and it did actually work. So it did do a reflow without damaging or burning anything like my very first attempt. So now I'm going to get set up and we will do a test reflow of a simple board. So this is one of the boards that I'm going to do. I make boards for the Mr. FPGA, and I pretty much ruined this when I was trying to do that. So I'm not too worried about anything else. So we just have a couple of components dotted around the outside of the board, and I'm using engineer solder paste, and we're going to do a preheat to 150 and then a reflow of 240, although it never quite gets there. Okay, so I think we can do this. So we can see the menu just there, and we can pan round and we can see the board. So I'm going to start it going, and we just go to reflow and hit the button. So now it's going to start to heat up to 150. You can just make out the blue line, which is the target that we're aiming for. So this is heating a lot more aggressively than I've had it before, but I still don't think it's heating quick enough to match a true reflow curve. So we have reached our 150-degree target, or within 1% of it, and we've now changed to a 2-minute soak period, which will maintain round about 150 degree or within 1%. So while that's doing, let's have a quick look if there's anything going on in here. So nothing interesting yet. We haven't started to work on any of the solder paste. So we're about 1.5 minutes into our soak. And we can see that it's maintaining this temperature within 1%. Okay, so now we're at our 2-minute mark, and we've gone to step number 3, and we see that the target has now changed to 240, and it's heating again. So now it's going to heat just as quick as it did initially to get up, or as close as it can, to the 240 degrees before it does a minute at 240 or as close as possible. So we can see some reflowing on the quad chip package, but that's not one that I've put on at the moment. That was there from there before. So we're up to 180. $200, and there we go. We can see those capacitors starting to reflow. There's another one there. I think that was the LED. Another capacitor. So we're still heating. We're at 230 now. So I haven't made a specific profile for this solder paste. So we could be going way over the top of what we need to. and we're almost at our target. So there we go. We've met our target temperature, all within 1%, and we've gone to step 3, which is now 60 seconds maintained at this temperature. And there we're maintaining that temperature quite nicely as well. It's a lot harder to maintain the temperature as it gets hotter. You need to apply more heat more often than you would maintaining a lower temperature. We can see that we've dropped down to 6%, but it doesn't matter, we've met our target. So now we've finished that 1 minute, and we've gone just to show the temperature now. So I'm going to leave it just for a short period, and then we'll open the door a little bit and let that cool down, and then we'll open the door all the way. We see our temperature starting to drop. So this potentially is the last issue that I need to fix, which is cooling down a lot quicker. And I really do think I should have brought a slightly better toaster oven, which had a circulation fan inside. Maybe I could activate that to increase the cooling, or I could put some kind of fan just here so that when it opens, it circulates air out, so it brings cool air in and the warm air out. Okay, let's open this all the way now. So what I'll do is I'll let this fully cool down, and then we will take a look at the board. But we can already see that everything is nice and shiny. So I'll have to inspect the board all around the edges, especially if there are any parts that were over the metal grills within the oven, to see if there are any problems. So we'll come back when that's fully cooled down. I think this is okay to have a look at now. The board's warm, but it's okay. Bear in mind, I wasn't that clean when I put the paste on. I think that's pretty good, considering that's the second time that I've tried this. I haven't applied the paste particularly well, but I would say that they have reflowed. What I need to do now, I think, is experiment with the temperature range for this paste. Try it at the lower temperature to see how that works. So there we have it. That is a successful reflow of some simple components on that board. I can't see any issues apart from the damage that I previously did. The reflow profile needs a bit of tweaking, but for a rough one and the first go, it's worked really, really well. So the next update for this series should be when I've refined the reflow curve and the time that it goes through the curve, and we do a more involved reflow of a board. I've got some that I need to do coming up, so we've got plenty of boards that we can do to test this out. Thank you for watching, And as always, I hope you found that interesting.